Howdy folks, back here again with some more thoughts on the Mandela Effect, and I'm not gonna lie, I'm also excited about trying out these new binaural speakers, so with me as I move to the left and the right, just playing around. Okay, but down to business. Now, that's also, if that is bothering you, that's just the shadow of my head. I'm trying to, I brought a lot of props along today. Feel free to laugh if you want, but it's like, what am I gonna need to tell my story in a few things? So I'm kind of moving around. There's a bunch of moving parts here, so that's why I'm getting up and grabbing things as I go. Okay, without further ado, one of the things that has bothered me for some time about people's explanation of the Mandela effect is there's a couple of things that we already know about memory and how it works, and a lot of the effects we're talking about are in line with these memory effects that we know. I'll just write down some of your normal effects that people are talking about. Remembering Berenstain instead of Berenstain, right? Remembering, was it Fruit Loops? Like this, instead of remembering Fruit Loops. What's another? Oh, here's a really good one. Remembering JC Penny instead of JC Penny. Okay. Now, the problem that I have with these types of things is that if you look at how memory works, we tend to remember things that are more common, more easily. There are, of course, exceptions to that, but when it comes to events that don't stick out a lot in our mind, things we look at day to day, we're far more likely to remember the actual spelling of a word than a spelling that we never use. This is a kind of a dominant response, is that we've seen fruit written out, we've written it out ourselves so many times that we're going to remember this far more easily than we'll remember that. And you can see this across all types of memory, this dominant response effect. So to me, if we are only seeing people remembering the more regularized version of words, you know, this is how you actually spell penny rather than someone's last name. It's how you spell the piece of money, then we're not really documenting. There's no, I mean to say, there's no way to show that we are documenting something more than a simple memory effect that we already know about. And that's something I think the onus is on us to be able to say, okay, this is more than a simple memory effect. And there's maybe a couple of different ways we can go about studying it. We can find examples that are contrary to this. And if anyone has any examples that are contrary to this, where we are remembering things that are actually spelled differently from how people usually spell that, I would love to see that in the comments. That would help a lot, I think, to show that the Mandela effect is real, that it is something separate of a normal dominant response memory effect that we see. But while I was thinking about this, it made me think about how we tend to regularize things as humans. We choose the way that we spell something as a society, and that's it forever. If you remember reading people in Shakespeare's time, they spelled everything so many different ways, but as a society, we got together and said, okay, we're all going to spell fruit the same way. We're all going to spell penny the same way. And with certain last names, some become more popular, others become less popular over time. It's kind of an effect that happens. I think of it kind of similarly to how you think of entropy. Apologies, my computer is having a really hard time recording stuff. I've got it mirroring, and I've got it with the microphone, like an external microphone, so I think it's just having a real hard time. It just restarted on me, and I can tell that there's some video problems. It's cutting out a bit as well. So I will do my best to speak slowly in case any of the video cuts out. So I believe I was just talking about entropy. And from a layman's standpoint, I believe that's talking about the energy level inside of a system. You want to have the entropy means the lowest energy level possible. But if I recall correctly, the mathematical version of entropy actually has a bit more to do with there being as little, I can't remember if it's high entropy or low entropy, where you have as little information as possible. I believe a high entropy system had a uniform distribution, and a low entropy system has a distribution where you have only one or two pieces of information that everything is inside of. So that a different way of explaining that, or an example, would be if you were to have the way that you spell fruit. If everyone spells it the same way, I believe, was that high or low entropy? I think that was a low entropy system. I may be getting them backwards. And if everyone spells fruit in a different way, and it's totally, it's totally random, I believe that was a high entropy system. So I only say this to let you know how I got to thinking about chaos theory from this type of thought about the Mandela effect, because it's an interesting idea, and I'd like to see if anyone else has had other similar thoughts. But if you think about it, what changes we are seeing is that we are putting in more energy into the universe if we start from one way of spelling fruit to multiple ways of spelling fruit. Okay. And I thought that that would be a really interesting experiment on the part of people at CERN. So let me tell you exactly what I'm thinking about. So I got this thought from reading a really interesting and funny and smart sci-fi. Yeah, it was a sci-fi book. I think it won a lot of sci-fi awards and a lot of fantasy awards. It's called To Say Nothing of the Dog, and it's just brilliant. And I had just read a book on chaos theory, and so it was just a lot of fun for me. Now, what's interesting about that system is that there's a universe. This is where I'm going to pull out my props, excuse me. And yes, you are allowed to laugh right now. That's totally acceptable. But I was just trying. It's a hard concept to explain. But what's going on inside of there that universe is that, say, there's a, let's just imagine that this is a universe, and you can get a lot of parallel streams that you can get people to go down, but it takes a certain amount of energy to get them there. So let me show you what I mean. Bust out my red lentils over here. Okay. See if this is enough. That's probably enough. Okay. And so, let's imagine this is everybody in the universe through all of time. And the universe is contained within itself. It makes sense within itself. And for the most part, as people are traveling through space-time, they're all contained inside of this one little muffin tin right here, this one muffin. You add more energy to the system, people start doing things they wouldn't have done before. This was kind of a time travel book, by the way, so they had people coming back in time trying to change the course of history. Now, if you imagine that this is what usually happens inside of the world, if you have like one time traveler come back, then you get a little bit of a change in the system, but they're adhering to the rules of that universe. World War II still happens, Hitler is still defeated, things like that. And if you apply more energy to the system, this is the interesting part of the system that I didn't get from reading the Chaos book, is you apply more energy and really strange things happen, but the system corrects itself. Okay, there you go. So you get a time traveler who, let's imagine they are, what could they do? They could change the course of history. They could let Hitler know, all the codes from the Allies or something like that, and they could push it like way up here, and that this represents that things have really changed from the original course of history. But until you get to a certain threshold, the universe reverts back to how it was, which is represented by the lentils going back down. So you're applying energy to the system, you're having, changes in the system, and yet the system itself says, nope, that's not enough energy, I'm going to pull us back to how things were. And Hitler doesn't win in the end in this example. But the idea is that if you got enough energy into the system, that you could push it over into another universe with an entirely different set of things going on, and you couldn't get back to that old universe without applying the same amount of energy to get back into that universe. So that was kind of the insight that I had gotten from that book, was because chaos theory in general is really interesting to me. But the insight I got is, what if the universe course corrects? And it's a pretty intuitive idea that you can see, since I can display it physically. It's a pretty intuitive idea where you can add time travelers, they can try and create paradoxes, they can try and do all kinds of things, but the universe course corrects and brings them back down into a high entropy state, I suppose. Is what the high entropy is, when everything's back down at the bottom. I always get high and low mixed up. But you can see what I'm trying to say is that there's a course correcting system. Okay? Now, how does this relate to what I just told you these guys, right? How are they at all related? So what I'm trying to say is maybe instead of the memory effect that we're used to seeing, where we tend to both regularize the spelling of words and we tend to remember the words as they are usually spelled rather than as how they're less commonly spelled. Okay, instead of that going on, what could be happening is that folks at CERN or wherever are applying energy to our universe and trying to see how high up the sides of this universe they can get. Okay, and so what that would do is, like, down at the bottom, if we're all down at the bottom, we all spell fruit the correct way. And they can apply energy to the system, make some changes, and now, in some cases, we're spelling fruit, F-R-O-O-T, and only in the cases where it's about that cereal, for example. And what's happening is some people are remembering how fruit is spelled in the high energy system, and other people are remembering how fruit is spelled in the low energy system. And why do we care about that? So what I think is happening here, this is kind of key to my insight, is that they don't care about changing the spelling of words. That's not how they're going to derive any power or get any use of the system. What the spelling of the words does for them is that it helps them understand the shape of the universe they live in, the rules of the universe that they live in. So imagine you're one of these lentils and you're totally blind to the shape of this muffin tin and to the shape of anything on this side. They're trying to see if they change the way that, like, Fruit Loops is spelled, the way that JCPenney is spelled. They're trying to measure how many people they can keep up here and how many people fall back down to the bottom. Because by taking that kind of measurement, they can see the shape of the universe that they live in. Why does this matter? This matters because, say, in a muffin tin, it's uniform on all these different sides, so it doesn't matter which side they go up to try and get out of this tin. It's going to be equally hard, but they don't know that they're in a muffin tin necessarily. So that's why it's important for them to test the boundaries of the side to see whether any different side is easier to get up than another side, which is why I think they're testing a bunch of different changes to the universe and seeing how many people remember this versus remember that, and then they measure that, and once they measure that, that helps them get an idea of the shape of the universe. Just to kind of drive that point home, I gave you an example where the muffin tin, it was a pretty uniform shape to the universe, but let's imagine you're on a timeline over here, and you're going up and down this timeline, but if you jumped at the right point in time, you could easily get into one of these grooves instead, right? So you can see you wouldn't want to jump over here. You'd want to wait till you were closer to that groove and you could just fall down into that side and then push your way up, because it doesn't take a lot of energy to jump from these top grooves to those bottom grooves down there if you know the layout of these contours, right? You can say this is the universe I'm in, and jumping from here to here is pretty hard, but jumping from here down to there now you can get into this kind of a universe. And so if they start testing, if they're over here and they start testing, they kind of push their boundaries on these sides, then they find these other grooves. And if they push the boundaries on these sides and find that they get pushed right back down, then they know not to keep testing here. You know, they just do some preliminary small tests here. And they do preliminary small tests along the whole arena. And then they notice that less people change back to the old way over here and more people change to this new universe. And that's how they realize with those small tests, they realize that they can get over here. So that's basically your, this is kind of your butterfly effect, right? With chaos theory, the insight of chaos theory is that, say your energy level is a 2, that you put into the system, and then usually that has an impact of 2, and that's your standard. You know, this is your energy into system, and this is your impact. Totally standard, not related to chaos really, that's just typical. And that's kind of the system I was talking about here. If you're, let me pull this a little closer. If you're trying to jump over from here over to here, you have to put in lots of energy to get lots of impact. Okay. But then you've got, inside of chaos theory, you've got your energy level again is 2, but your impact is, say, like 5, and this is the butterfly effect we're so used to hearing about, right? Right? What's the energy level that a butterfly imposes on a system is tiny. But if you imagine that it creates I forget, they create a storm or something somewhere else, then so that's a tiny energy level, high impact. So that's what chaos theory is about. And that is represented over here by saying, okay, I'm on these grooves, and I just changed something small over here, and suddenly, boom, I'm down into these grooves on this side, right? This is where chaos happens. This is your normal area, and this is affected by chaos, and you can have a small energy change leading to high impact, get into a totally different time stream with totally different things going on. So they're basically trying to say, when they create all these small changes, and they see small impacts, then they say, okay, small changes, small impacts, I'm over here in the system. Small changes, big impacts, I'm here in the system, and I know I can go this direction. So I think that's what's happening with all of the small spelling changes and everything. They're trying to assess the contours of the parallel universes that exist out there, and once they assess those contours, they know, once they see the impact that they have, they know the contours, and they know what they can change. So that's my 2 cents, and I hope that made sense, and I'd love to hear your thoughts on that, and whether you think that there are any examples of Mandela effects that go against what I talked about earlier with the regularization of words, that we actually remember things in the opposite direction.